Hello friends, welcome to Delta Science. In this video, we are going to derive the expression for current in terms of drift velocity. Okay, it is nothing but derivation of the equation I is equal to NEA VD. N means number of electrons, E is charge on the electron, A is area of cross section of the conductor, and VD is drift velocity of the free electrons inside the conductor. Okay. Description is, consider a conductor. Conductor is nothing but your just wire. Okay, this is a conductor, means just a wire. Okay, in this video this wire or conductor has been enlarged, okay, just to show the electrons inside those inside that conductor. Okay, these electrons, they travel towards the positive terminal of the battery after applying electric field. Okay, the current inside the conductor is nothing but flow of charges with respect to time. This one we know that. So we have to find out this expression for electric current in terms of drift velocity, in terms of which we have derived in the last video. Now for this we need the total amount of charge Q and also time taken by these charges to move from one end to another end. Okay, so first we have to find out Q and after that we will come to T part. Okay, time taken for this electron to move from one end of the conductor to the other end of the conductor. So first we have to find out the total charge inside the conductor. Q is equal to, so there will be n number of free electrons inside the conductor. For that we will write n. Okay, so n number of electrons E. Okay, there will be n number of electrons inside the conductor, that is the reason n into E, and the total volume of the conductor. Total volume can be defined as length into area of cross section. If we consider this pen as a wire, this is the length of the conductor. Okay, this one is the length of the conductor and area of cross section is the circular part. Okay, this is area of cross section and this is length of the conductor. Okay, it means length into area, A into L, is nothing but total volume of this conductor, total volume of this wire. Hence there will be n number of electrons will be present inside this volume. Okay, so in this pen, if we consider as a this pen as a conductor, there will be n number of electrons will be present throughout the volume of this conductor. Okay, this is the meaning of this equation. Okay, Q means total charge. Total charge is N E A into L. A into L is nothing but volume. N number of electrons present inside this volume. Okay, next this one we take it as equation 2. And second one is time period. Time period for these electrons to move from one end of the conductor to the other end. Okay, so we know that time is nothing but the total displacement divided by velocity. Okay, the total displacement is nothing but length of the conductor, because the electron is traveling from one end of the conductor to the other end of the conductor. It means it is traveling the distance L. Okay, L is nothing but displacement divided by the velocity of the accelerated electron. Okay, this one is equation 3. Now substitute equation 3 and 2 inside the equation 1. Substitute equations 2 and 3 in 1. Okay, I is equal to, Q is N E A L divided by, T means time period, sorry time. Okay, L divided by VD. Here L cancels out. I is equal to, this VD comes to the numerator, N E A VD. Okay, here I is electric current electric current, and E is charge on the electron, A is area of cross section, this part, okay, area of cross section of the conductor, and Vd is the drift velocity of the accelerated electrons. Okay, these electrons accelerated just because we are applying electric field, we are applying battery. Okay, I equal to NEA Vd is the expression for current in terms of drift velocity. Okay, thank you.